Okay guys, so what I've done is I've pulled together some topics that I feel might come up on paper number 3 for your GCSE Maths Edexcel. Now these are past exam questions, so you may have seen them before, but it's more to give you guys guidance on methods. So the final answer is not so much what we're after. In fact, I'm not going to even check what the answers are. So hopefully, if I do make any mistakes, some of you guys will pick it up anyway. But it's the methods, okay, what to do when you see these questions. Because one of the things that I say to my students is, look, there's no point learning a question, learn the topic, okay, understand things, understand the nuances and things like that, okay? So let's go. Right, there are 16 questions on here of different types. I'm going to go from sort of easy questions, medium, to the more difficult ones at the end. Right, so the first one here, we have this table and we've been asked to draw the frequency polygon. One of the things that I would do is I'm also going to tell you some of the misconceptions that students make when they're doing certain questions. So here, one of them is like, they forget to find a midpoint. So they end up drawing bar graphs. All right, they look at the 140 to 150 and they see the 7 and they end up drawing bar graphs rather than plotting that 7 on the midpoints. So as you can see, we don't have the x-axis any details filled in, nor for the y-axis, so we're going to need to do that first. So on the x-axis, this will go in, so 140 to 190, and we have to find a way to break it up. All right, so I'm looking at maybe tens. Let's see if that works. And you can start on 140, by the way. All right, you don't have to start on 0 here, because something that students often ask me. Sometimes you may see this little line, like that thing, and then you start on 140, but you're good to go. That's why can you see there's two little things here as well, okay? But if you're not comfortable with that, then just write a 0 and then do that dot and then start on 140 or something like that, okay? But I'm going to start on 140 right there, and I said I'm going to go up in tens all the way up to 190. Okay, so let's see if that fits. So we got 150, 160, 170, 180, 190. That was nicely done. And on the y-axis, I'm going to need to go from 7 at least to around the 30s here. Okay, so I have to think of a way to break up that y-axis now from 7. And here I'm going to be starting from 0. So let's put that 0 in there. I think I could do tens, right? 10, 20, 30, 40. Yeah, that's great. And all the smaller squares, they could be like 1, 2, 3, 4, etc. Whereas on this one would be 145, for example. All right, and this will be 155. So it's all about plotting now. So the first one, we're going to plot the 7 on the midpoint, in the middle of these numbers, okay, which is 145. So 7 on 145. So we're going to have to find 145, which I showed you before, and then go up and count 7. So 7 is right there. So there, that's the first mark done. Then we've got what, 25 on 155. Okay, so 155 and 25. That's right there. Then we've got 34 on 165. So 34, 165, right there. 29 on 175, 29 on 175, which is here, and 29, I need to go and put that right there. And then we've got 16 on 185, so that should do that. Now, what do you do after this? Do you get a freehand and curve or something? This is sometimes students get confused with that too. You get a ruler. Now, this is okay. I mean, you can leave it like that, but what I say to my students is, look, it did ask you for a polygon. So really, polygon is a shape, a multi-sided shape. And what I say to them is, look, it goes all the way down to 140 and all the way up to 190. So it's better to take this and join it up here and here with a ruler. All right, so that's something that I tell my students to do, because this way you complete polygon with this x-axis here. It's a complete shape now. Well, there you go, see? But yeah, if you do decide not to do that, that's fine, because I have seen that in mark schemes and answers in the back of books. So yeah, all good. Right, let's move on to question 2. We have a box plot question. Right, first part says to sketch a box plot using the information that you've been given in here. And okay, I'm going to use their scale to do this, and the second part of this is to compare the distribution. So this one is the boys who took some time to complete a puzzle, okay, because we're going to have to plot it on here. I'm just going to borrow the axis, saves me drawing it. So the first part is sketch this, okay. Right, what do I start with? I always like to start with the median. So the median here is 18, so I'm going to have to find 18. So that's right there, the median, 18. I'm going to have to find this here. So that would be, what's that, 10, that's 15. Okay, so I have to work out what each of these squares are. I think it's 11, 12, 13, 14, 15. So 16, 17, 18, like that, okay? So what do I want? I wanted 18, didn't I? So 15, 16, 17, 18, right there. I want to draw my median line right there. So let's just do it there, like that. Okay, we're going to have to ignore this. This was part of here when I copied it, all right? So just ignore that. Right, the upper quartile is 23. Sometimes, by the way, you have to work things out. Look, so you see here, you've been given the upper quartile, but you've not been given the lower quartile, but you've been given the interquartile range, all right? So if you know the upper quartile is here and the lower quartile is there, and the distance between them is your interquartile range. Okay, so therefore you're going to find the lower quartile, you're going to do upper quartile, take away the interquartile range, and then that will give you the value here. Okay, we'll do that in a second after we actually draw the upper quartile. So that's 23, yeah? So 20, 21, 22, 23, right there. So there we go. Make sure you do that with a ruler. And now we have to find that lower quartile I said we need to find, yeah? So we're going to do 23, which is the upper quartile, take away the interquartile range, and that will give us the lower quartile. So let's take away 8. So get your calculator if you want, or do it in your head. That gives us 15. So 15 is right there. That's all good. Right, we are ready to box this up and have the main part of our box plot. So we've done the median, we've dealt with the upper quartile, and we've dealt with the interquartile range when we were finding the lower quartile. Now it's about the minimum. So the minimum value is 12. So again, 11, 12, right there. We're going to draw a line right there, here. You can draw it big or you can draw it small like they have. It's totally up to you. Okay, I like to draw it like that actually. And that's that minimum done. And then the maximum is 29, which is right there. So there. Remember, you're going to have a full grid in the background, I hope. So you won't have to do this on plain paper like I have. Right, so this is our box plot done, comparing the distribution now. So usually when you're comparing, so this was the boys I've done, right? So this was boys, and this is the girls, okay? All right, I have to compare. I have to like sort of say something about, usually about the median and the interquartile range or the range. All right, so what can you see? Remember, it's the times that they took to complete the puzzle. So the boys, if you look at the median, immediately the boy's median, the average time that the boy took was longer, all right, because higher, right? So the boys, what we can say is boys took longer. Boys, on average, according to the median, all right, took longer to complete the puzzle. They have a higher median. So do make a reference to the median. That's one mark. Usually there's 2 marks. And the second thing, what can we see here? Look, we can, like I said, interquartile range seems to be quite similar. In fact, let's quickly calculate the girls' interquartile range. So that is what's that? The upper quartile. That's 16. That's 17. So the upper quartile is 17, and their lower quartile is 11. If we do 17 take away 11 for the girls, that's 6. So the girls' interquartile range is 6, and the boys' one was 8. So that means the boys had a larger interquartile range. I mean, it is quite close still. I mean, we can write it down. So, I mean, boys had larger interquartile range. Now, what does this mean? If the interquartile range is bigger, it means less consistency than the girls. You could sort of say that. But like I said, they were quite close, 8 and 6 as an interquartile range is quite close to compare. Maybe we could look at something else, perhaps the range, the overall range. Okay, so the boys took longer They had a larger IQR, so therefore less consistent. But you can talk about the range as well and the highest value. Right, question 3, we have indices. Right, so look, often people forget that this powers the number as well. All right, so don't forget that. So this is what I would write. I would write 5 cubed and then x cubed like that, and then that. You don't have to do it like this. Again, you can just go and calculate them straight away, but this does help you remember. So 5 cubed, that is 125. And what do you do when you have this? You multiply them. So that's x to the power of 9. And again, same for this, 2 times 3, that's y to the power of 6. So this is your final answer. All right, this part. So 10 and 4, we are dividing. So we can divide both of them by 2. So we can divide 10 by 2, that gives us 5. 4 by 2, that gives us 2. So we're going to have 5 on the top and 2 on the bottom. Now, when it comes to dividing those, we take them away. Can you see they cancel anyway? So because they have the same power. So p is not going to exist anymore. We are going to get rid of the p. With the q, that's going to be 5, take away 6, leaving us with a negative. So we can choose to write this negative up here like that, or we can leave just a q down there, okay, because there's reciprocal involved as well. Okay, remember that. So whichever way you're happy with that, guys, you can do it. Or you know what you could have done? You could have just wrote 5 over 2 for the first part, q minus 1 like that. And now r's not cancelling with anyone, that belongs to the top, stays there, and then you can just add r there if you're doing this version, okay? But I think most of you would probably do that, okay? So that's good. Let's move on to question 4. There are 4 starters, 7 mains, 4 desserts in a restaurant. Work out the total number of ways of choosing a starter, main, and a dessert. So product rule for counting. So 4 times 7 times 4, that's your starter, that's your main, and that's your dessert. And just multiplying them. So put that in your calculator. 4 times 7 times 4. There are 112 ways of choosing a starter, a main, and a dessert. Now I've also included this part, this type of question, because sometimes students get confused with this. So I'm going to quickly show you this. So there are 30 students in a class. 2 students are going to be selected to receive a prize. How many different pairs of students could be selected? So you can have the first student there and the second student there. Okay, now from the first student you can pick, for the first student I should say, you can pick out of 30 students. Now because you've already picked one, when you go and pick the second student, you're going to have one less student because you've picked one for the first position. So here you're going to have 29 students to choose from. Okay, so you're going to do 30 times 29. However, it could be the other way around. So you have to divide the results by 2, otherwise you're repeating it. So this 30 times 29, you have to divide this by 2, and that would be your actual answer. That gives you 435 ways. Okay, so let's move on to the next one. Question number 5. This is capture-recapture. So Safud wants to estimate the number of deer in a forest. He catches a sample of 40 deer, tags them, releases them back into the forest. So that's the first part. So he gets, he catches 40 of them. Now we don't know how many deer there are in the forest. We could write D for deer or N for the number of deer, whatever, okay? Then the following week, he goes back out again and he catches a sample of 40 deer. And he notices that 5 of these have been tagged. So what you want to do here is write equal, and now he catches 40, and out of the 40, he finds that 5 of them have been tagged. This is how you set this up. It's simple. Now, what you need to do is make n on its own. Now, what you can do here, you can multiply this there and this there. So you end up with the following. 40 times 40 is equal to 5 times n, like that. And then you can get rid of the 5 now, okay, by dividing the other side. So 40 times 40 over 5 equals n, and that will give you your answer. Let's put that in our calculator. 40 times 40 divide by 5, that gives 320. So we are estimating that there are 320 deer in the forest. Now, any assumptions that you make, we have made an assumption that, you know, when he catches them the first time round and he comes back a week later to do this again, none of the deers have run away. None of the deers have unfortunately died. None of the new deers haven't been born, that the population remained the same. Okay, so that's an assumption that we make here. All right, let's move on. Question number 6. All right, so I have seen these come up quite a lot on some practice papers, so it's good that we practice this. So Matt wants to invest £8,000 for 3 years. He can choose between Bank A and Bank B. Now, Bank A pays the following: 1.2% compound interest per annum. And Bank B has got this rate where it pays 2% in the first year and then 1% after that. Which bank will give the most money after 3 years? Bank A, we're going to start with first. So it's for 3 years. He's going to invest £8,000. Right, I'm going to use a formula. I'm just going to remind you quickly of a formula that I'm using in case anyone doesn't know. Original amount times by the multiplier to the power of n is equal to the new amount. Okay, original amount is how much I'm investing, 8,000, and I'm doing it for 3 years. Okay, so what's my multiplier for the Bank A? So if it's 1.2%, I'm going to do 100 plus 1.2. I'm just going to quickly show this to anyone who doesn't know how to find multipliers. So 1.2%. Okay, so all I'm doing is I'm adding to 100% 1.2%, which is what the bank's giving me, and then this is the amount. To get a multiplier, I divide that by 100. So that will be 1.012. So my multiplier here will be 1.012 to the power of how long is he doing it for? For 3 years. Put this into my calculator now. Gives me £8,291. Round it to 2 decimal places because it's money. So I've got 4698. I'm going to do that for you so I can show you. All right, so that 9 is going to make this into a 7. So it's going to be 47 there. Right, so can we see how much we get? Right, we get an additional from 8,000, we get an additional £291.47p. So let's write that. So £291.47p. This is how much the bank gives. And Bank B now. So Bank B, where you're investing £8,000. The first year you get 2%. So 2% we're going to do the same way, guys. Yeah, 100 plus 2%, which is 102%, and make that into a multiplier. So it's going to be 1.02. And for this one, it's going to be 101%. And to make that into a multiplier, we're going to do 1.01. Okay. Right. Now for the first year, we get the 2%. So it's going to be times by 1.02. And you can draw the brackets and put to the power of 1 if you want to, just so you know. And then we're going to keep that there because now for the second year, we're going to get that 1.01 multiplier. So 1.01. And that is going to be for how many years? Remember, the total was for 3 years. We've got 1 year already taken. So this is going to have a power of 2. So to the power of 2. So let's put that in our calculator and see what it gives us. That gives us £8,324 and 016. So that's going to be £8,324 and 02. There you go. So how much is that extra? That is an extra £324 and 2 pence. So Bank B gave more money. So you'll say Bank B is better or gives more or whatever. Okay. Right. Question 7. Right. We have 3D trigonometry. All right. So we've been asked to calculate the angle AFC. Right. So AFC right there. So what is AFC? The angle AFC. So A to F to C. We are looking for that. Okay. So in our diagram, we're looking for that angle. So how do we find it? Let's draw this triangle out first. So this is important. Draw that triangle in pink that I've just highlighted. So our right angle is there for our triangle because it's not this one, by the way. It's there, like that, okay, along that line. There's our right angle triangle. So that's F, that's C, and that's A. And we are looking for this angle right there, okay? So we don't have any sides, as you can see. But if you use this triangle here, we can find that side right there, F to C. Okay, because that one, we have an angle here and we have a side. So we can find FC by using the triangle on the side. So let's go ahead and do that. So that's FC, and that's 30, and that's D. and that's 7 centimeters. So if we label this according to trigonometry, that's adjacent. We're looking for the opposite side, our x, and we can now use, let's do it down here, we've got more room. We can now use SOHCAHTOA to do this. So SOHCAHTOA. So we have opposite, and adjacent means tan. So that's going to be tan 30 is equal to opposite, which is FC, over the adjacent, which is 7. If we rearrange that in terms of FC, we get 7 times tan 30. Reach for our calculator, 7 times tan 30. That gives, it's in third form. You can keep it like that if you want to, because you are going to use it elsewhere, but I'm just going to quickly round it, and I'm going to leave plenty of decimal places. All right, that's enough. Okay, so that is FC. What is that? Centimeters. Right, now I have this side, which is 4.04145. okay, a bit long. Yeah, you could have done 4.04. That wouldn't be a problem either. Okay, in case any of you think that. Right, so I still need one more side though, you know, maybe AC, okay, or that. Now AC seems more likely to be easier to get actually. So look, on the floor, if you see here, we have another right angled triangle, and we have two sides. So if I draw that out, so you can see it. So this is A to C on the floor, let's do it like that. There, A to D, and then we have that. So that's that. So that's A, D, that's 10 centimeters, that's 7 centimeters, that's C. And we want to find A to C, right? Because we need A to C here. And that's using Pythagoras. So A to C is the hypotenuse. So it's going to be AC squared. I'm just going to do Pythagoras quickly with the square root and everything, all right? So 10 squared plus 7 squared. So that's going to be square root of 100 plus 49. That gives me, again, sorry, that shouldn't be AC squared, by the way. That's just AC, because I just square rooted it already. So that gives me 12.2066, if I rounded a little bit there. Okay, right, so now I can put that for AC, 12.2066. This is what I have. Now I can find my angle X. So let's bring this here and find X. So we need to label it first. So this side here would be opposite. This side here would be the adjacent, and I'm using tan again. So tan X is equal to opposite, which is 12.2066 over adjacent, which is 4.04145. When I'm finding the angle, I do the inverse. So the inverse of all of that. So I'm going to just do that on my calculator here. So inverse tan, that gives me 71 point, what is it, 1 decimal place. So 1 decimal place I have to round it to. So 71.6809, that I could say 71.7 degrees to 1 decimal place. There you go. Right, moving on. Remember, I'm not checking in on the answers. So if I do make any calculation errors, guys, just forgive me and just correct it in the comments, okay? I'm not checking any of the answers, okay? They should be fine, hopefully. Right, question 8. Work out the area of the triangle. This is a non-right angle triangle. A lot of you guys keep doing base times height divided by 2. This is only for right angle triangles. This is a non-right angle triangle. You are using the sine rule. Now, if you look at this, very straightforward. This one, because everything's given to us, you're always looking for those little things. So if you've got this angle, this side, and this, you can use your sine area rule. So it's two sides and the included angle is given. You can use this rule, which is half AB sine C. You don't even need to label it, because if you see that pattern, you know what you're doing. So half times A, which is 15, times B, which is 16, times sine 100. Put that in your calculator. So 0.5 times 15 times 16 times sine 100. Make sure you're calculating the right mode, not in radians, because you're going to get the wrong result. So 118.3 significant figures. I've got 1769 ... So free SF would be 11 8 centimeter, yeah, centimeter, yeah, squared, because it's an area. There you go, done. Okay, moving on. Question number 9. Here we have to work out the area again, but look, we don't have that thing I was showing you earlier. Look, we have this angle, we have this side. It'd be nice to have this, and then we could have done it, but we don't have it. We can't use this angle because we don't have this side, nor do we have that side. Okay, so we have to find this angle somehow. Okay, how do we find, sorry, not the angle, the side somehow, so that we can do this, okay, and find the area. But we have to find a way to get there. So how is the question? Well, I can't use the sine rule because I don't have this angle, but if I look at this carefully, I have those two and I can find that angle, right? Because the angle is in a triangle. So to find this, I can use 180 minus 82 minus 40 and get that angle. So 180 minus 82 minus 40, that gives us 58 degrees. Now I can find this because I can use the sine rule with that one. Okay, that can use the sine rule now, and therefore, oops, therefore what do I have? I have x over, that's what I'm looking for, sine 58 is equal to 12 over sine 40. Rearrange this in terms of x, so move the sine 58 to the other side. That gives me, you could do it like this if you want. Some students prefer this. Okay, I prefer to just put this and add it on there and then one fraction, but it's okay, whatever you do. And that gives us x is equal to 15 point, so we round it to 1 dp, 15.8 centimeters. Right, we've got, if we draw this triangle out now, just so that we know what we've got this to be 40. Actually, we don't even need that, forget that. So we've got our x 15.8, got this 82, and we've got 12 centimeters. And we can use the sine rule, which we used earlier to find, sine area rule, I keep saying sine rule. Half times AB, which is whichever one, 12 or 15.8. So 12 times 15.8 times sine 82. Put that straight into your calculator. That gives us 93.1 dp, yeah, 193.9 centimeter squared. All right, question 10, cosine. No, maybe, hopefully, because I need to put a cosine in there. Right, so we need to find this, but again, look at this triangle. We don't have anything, we need another side. Yeah, we've got that, maybe we can find this side, and that's what we use this triangle for. So if we use that triangle and find this, so let's draw that. So that's 40. That's 10 centimeters, that's 13 centimeters, and we want to find that. It's a non-right angle triangle, and we're going to use the cosine rule to find this. So we're going to label this now. So A, small a, B, small b. B and C don't matter. A, I want to keep that A, you know, the opposite pair that I have, and C and small c. So the cosine rule is a squared for sides. A squared is equal to b squared plus c squared minus 2bc cos a. Okay, so a squared is equal to b squared. What's b squared? 10 squared plus c, which is 13 squared, minus 2 times 10 times 13 times cos 40. Now, don't be a hero and put all of this into your calculator, please. All right, just do things slowly. Do just this part first. All right, so do 10 squared plus 13 squared on your calculator. Get the answer, 269. So 269. Then do this part. So that's 2 times 10 times 13. That's 260. So 260. And then cos 40. Okay. Now, again, don't do this. A lot of students, they say, should I do 269 take away 260? I said, never. How can you? This is being multiplied. Okay. So you're doing, 269 take away all of that. All right, so please be careful of this. But I'm going to put this all into my calculator. I'm going to use brackets. So I'm going to have 269 minus bracket 260. You don't have to use a bracket because the calculator is quite smart, because the calculator opens up its own bracket for this. You have to close that. So if you do use bracket, then make sure you close the other one. So this bracket here is closed right there. Okay, because the calculator, when you press cos, opens up a bracket for the angle. All right, so let's go put that into our calculator. and then that gives you A is equal to 8.3563 dot dot dot. Is that 1 dp we need it to? So 8.4, and that's length centimeters. Well, actually, you know what? You could keep it longer, because remember, we're not supposed to round here. It's this that needs to be rounded to 1 dp. But it's okay, you know. Let's make it 35. What am I doing here? Let's make it 36. Okay, so it's still 2 decimal places is better than 1. So 2 dp. Right, now if we look back at this triangle, we know this length right now, so we can draw this and work out the angle. Sorry about my dodgy drawing. That's x, that's 5 centimeters. We have a right angle, and this is 8.36. And here we go. So if we apply SOHCAHTOA, so adjacent there and opposite, we seem to be using tan all the time. So SOHCAHTOA, this is tan again, guys. I was hoping we'll have a different experience, but yeah, there you go, tan again. So tan x is equal to opposite, which is 8.36 over 5. And again, we find it in an angle, so the inverse of tan, 8.36 over 5, and that gives us 59.1169 dot dot dot. And if we round that to 1 decimal place, that's 59.1 degrees. Okay, there we go. Let's keep going to the next one now. Question 11. Right, write down the nth term of the quadratic sequence. Now, different people have different methods they might use for this. All right, some people use the algebra. They write ax plus b and everything. But I use the method where I'm just finding the differences. So if your answer matches mine at the end, it's not a problem. Okay, so this is our sequence. We're going to find the difference between each term. So we can see that's 8, 14, 20. Right, now I'm going to find that the differences have their own difference, and that was 6. What do we do now? We half that difference. We half the second difference. So because it's 6, we half it, that's 3. If that second difference, for example, was a 4, we'll half it, we'll get 2. If it was a difference of 1 here each time, we half it, we get 0.5. And we write with an n squared. Remember that? Okay, but our one was a 6. So we half the 6, we get 3, and we write an n squared. Next, we write a table. Okay, we draw our table. So here on our table, we have the original sequence, okay, which is the 2, the 10, the 24, the 44. And then we write down what we found, so 3n squared. Okay, like that. And then we're going to find the differences of that. So here, this is the first term, second term, third term, fourth term. Okay, we're going to put the 1 as our n. So we're going to do 1 squared, then times by 3. 1 squared is 1, times by 3 is 3. Then we're going to put the 2 for our n right there. So 2 squared is 4, 4 times 3 is 12, like that. Okay, then we do 3 squared, which is 9, times by 3, which is 27. 4 squared is 16, times by 3 is 48. Now we're going to find the difference between these terms. So 2 take away 3 is minus 1. 10 take away 12 is minus 2. 24 take away 27 is minus 3. 44 take away 48 is minus 4. This would now be a new sequence, which is linear. Okay, so treat this as you would any linear sequence. So find the difference between each term. So what we're doing between each term, it will only be one difference. So we are taking away 1. We are taking away 1 each time. So write minus 1n. You don't have to write a 1n, by the way. You can just write minus n. And then you go to the first term and you go forwards by whatever you went forward with this way. Going backwards, I meant to say, was plus 1. Okay, so going forwards was a minus 1. So going backwards would be to add 1. Right, so we add 1. And then minus 1, add 1 is 0. So that would be 0. So you add a 0. You don't have to, but I'm just showing you. And now that's it. You put this and that together. All right, so you write 3n squared minus 1n plus 0. But you don't need to write the plus 0 on this one. And this is your nth term of the quadratic sequence. And what you could do in an exam, because sometimes students like to know there and then, some questions you can know there and then whether it's correct or not. What you can do is take the third term or any term, but here we're taking the third term, right, and test it out. So if you put 3 in here and 3 in here, does it give you 24? Let's find out. So you could do this with your calculator. So 3 bracket 3 and square it, and then take away 3 again. And that does give us 24. Okay, so you can check that and know that this is correct. Okay. Right, question 12. Given that f of x is equal to 2x minus 4 and g of x is that, find gf3. Okay, so look, here we've got a composite function. Sometimes the question might be, by the way, find, let me write it properly. It might just be find gfx, okay? If you've been asked to do that, all you do is take f and put it into g. So you take f and put it into g's x, wherever that is. Okay, so that'll be 3 bracket 2x minus 4 and then plus 5. Okay, that's it. You don't need to expand it out, and that is gf of x. Okay, you can expand it out though if you want to. But this question isn't asking us for gf x. It's asking us to put 3 in there. The best way to do this, guys, you don't need to find the expression. Start off by doing f3. Always, this is the first one next to the bracket. Whatever letter is next to the bracket, you start with that. So f3. So I'm going to put 3 in here. Okay, so that would be 2 times 3 minus 4. That's 6 minus 4. That gives me 2. Now take this 2 and put it into g. So whatever you got from here, now you're going to put it into g. You got a 2 from there. You're going to put that into g. G's x. So that's going to be the following. G of 2 is equal to 3 bracket 2 plus 5. That is 6 plus 5. That gives us 11. So that means overall, if I took a 3, I put it into f, and then I put the result into g, I get 11. So therefore, gf3 is equal to 11. Okay. Part B, it says work out an expression for the f of minus 1, which means inverse. This means inverse. So you take that and you find the inverse. So you take f of x, but you write it with a y equals 2x minus 4, and then you make x the subject and then replace it at the end again. Okay, so I'm going to make x the subject. I'm going to take the minus 4 to the other side, so I get y plus 4 is equal to 2x, and then I'm going to divide by 2. So x would be equal to y plus 4 divided by 2, and therefore the inverse of that would be, I remember I replaced the y with an x again at the end. All right, so x plus 4 over 2, and that is the answer. Now, one thing I saw one of my students do, they try to just write this, and then they go and replace y and the x there and then. That is not what you do, all right? So please don't do that, okay? You have to make x the subject first and then do the replacement, okay? Right, then it says solve this, f of x equals g of x. Okay, this is actually quite straightforward. It's just saying that make this equal to that, and then solve it. So let's go ahead and do that. So that is part C. So 2x minus 4 is equal to 3x plus 5, and this becomes a linear equation that we have to solve. So I'm going to take the 2x to this side because it's smaller. So 3x minus 2x is just x. I want to take the 5 to that side by taking away. So minus 4 minus 5, that would be minus 9. So therefore x is minus 9. That's the answer to solving that. All right, question 13, we have iteration. Now, there are different types of iteration questions. I've just chosen one that's quite popular. Sometimes they might ask you to make something the subject, show that this equation gives you this root or whatever, okay? But this is more common, all right? So the other one, by the way, is just changing the subject of a formula. So as long as you're comfortable with that, get practice on that, you should be okay, all right? So this is mainstream iteration, all right? So you're starting with a value, and you have to find x1, x2, x3. So I'll just quickly explain the mechanism of this, all right? So what happens is, you know, when you're this equation, you know, you got n plus 1, and if you got n plus 1 and then you've just got n, ignore the square here, yeah? So if you've got n plus 1, xn would mean the one before n plus 1, because if I have xn and I write the next term, that would be n plus 1. If I write the term after that, that would be xn plus 2. Okay, if I write the term after that, that will be n plus 3. So if I'm referring to something that comes before xn plus 1, it means that xn, okay, that comes before that. So if I have x0 and I'm trying to find x1, okay, I will do 5 over x0 value, square that, and then add the 2. If I'm finding x2, I will do 5 over x1 will now go in there because that's the term before x2, square that plus the 2. All right, so on and so forth. If I'm finding x3, I will do 5 over x2, square that plus the 2. All right, so this is something just as knowledge. Okay, just park it up there. So what you want to do here is on your calculator, just press to find x1 on your calculator, write 2.5 and then press equals, and then that 2.5 goes into your calculator's memory. And then you'll do, in fact, I could show you this, 1 second. See, what we're going to do is we're going to do x1, we're going to do 5 over 2.5 squared plus 2. All right, so this is how you do it. So you press 2.5 on your calculator, press equals, clear the screen. That 2.5 has gone into your calculator's memory and it becomes your answer button. So now you can press fraction, 5, go down, you're going to press answer, square it, make sure that you do this part properly. So press the arrow to the side and then plus 2. It looks complicated on this calculator, but it won't be as complicated on yours. So that gives me an answer of 2.8 for x1. Now to find x2, what I need to do now is just press equals again. So if I press equals, there, it gives me 2.637755, and then if I press equals again, that will give me x3, and that's all I need to find. So 2.718622 ... and there you go. That's your answer for that. All right, question 14, we have algebraic fractions. So with this, what you want to do is make the denominators the same here. So we can take this, multiply there, take that, multiply there, and then multiply the bottom together, which will eventually multiply on that side. All right, so first step, 7 bracket 3x minus 2, then minus 4 bracket x plus 1. I'm going to put this over one fraction because I'm multiplying the denominators. There we go, equal to 1. Now I can take this and multiply it there, so I can get that out of the way. So, and also expand that in a bit. So let me just write this out again. And then because I'm multiplying all of this with a 1, all right, instead of putting that in brackets like that and still having the 1, just put that in a bracket because it's just multiplied by 1. So it's the same thing there. Let's go expand those brackets now. So we get 21x minus 14 minus 4x minus 4. And here we get 3x squared. So I'm multiplying this way. Okay, like that. So 3x squared minus 2x plus 3x minus 2. Let's just collect the like terms on their respective sides first. So 21x minus 4x gives us, what was it, 17x, and then minus 14 minus 4 is minus 18. And on this side, we just got 3x squared, and then minus 2x plus 3x is plus x minus 2. So we've got quadratic going on here. I'm going to take this over to this side. So that gives me 3x squared, and then 1x, take away 17x, which is minus 16x, and then minus 2 plus 18, that gives me plus 16, and that equals to 0. So I can write it out with the 3x squared part first, and then I look to see if I can cancel down anything, divide by anything, which I can't really, so I'll leave it as it is. Right, I need to factorize this to find the values. All right, so you could try and do this, but you know, you probably sit around for ages trying to figure out what the value should be, and we haven't had a quadratic formula being used, so I want to use the quadratic formula here. But you could do whatever. So a equals 3, b equals minus 16, c is equal to 16. So the quadratic formula is minus b plus or minus square root b squared minus 4ac all over 2a, and that is for your x. So if we use that and apply that now, that will be minus 16 plus or minus square root. So we've got minus 16. Hope I've got enough room. In fact, let's move it down here. Get rid of that. Let's move it down here. So a squared minus 4 times A, 3 times C, which is our C. That's all over 2 times 3. Okay, so now we're going to have to tidy this up. So minus 16 is a plus 16. And then this part we'll do on our calculator. So minus 16 squared, that gives us 256. And then that is 4 times 3 times 16. So minus 192 all over 6. So if we work out the square root first, so 16 plus or minus 256 minus 192, that's 64 over 6. That 64, by the square root of 64 is a number, which is 8. So you could use that. So you'll have 16 plus or minus 8 all over 6. That gives us 16 plus 8 over 6, or 16 minus 8 over 6. And for the first one, 16 plus 8 divided by 6 is 4. And for the second one, 16 minus 8 divided by 6 is 4 over 3. So these are your final answers. Okay, moving on. Question 15, we have a bounds question. So you've got G and H, which have been rounded to 3SF, and you've got to consider bounds and work out the value of F to a suitable degree of accuracy, given a reason for your answer. All right, so let's start off with G first. We are going to find the upper and lower bound of G, which is 12.7, and it has been rounded to 3SF, so the next SF will be 12.8. And this one before that, 12.6, and we're going to go and find the lower bound and the upper bound. So for the lower bound, it's going to be 12.65. For the upper bound, 12.75. So that's G. And then for H, we're going to do the same thing. So we've got 9.294. Okay, we're going to fill this in, 9.295. Okay, so you know this decimal place has been rounded to 3dp. This is the third decimal place, so we're just increasing it 1 by this going up. That's the next third decimal place, and we go backwards on the one before that. So 9.293, and then we're finding the values in the middle. So for this one, it's going to be 9.2935 and 9.2945. Okay, so this is our bounds done. Now, when we're finding an F, when we're doing division, we always want maximum that we can get on the top divided by minimum for the maximum. And when we're doing F and finding its minimum, we want to do minimum divided by the maximum. Okay, so what do we want for the maximum? We want the G on the top, and I know it's under a square root, but the maximum that we can get out of the top is if we use this. Okay, so it's going to be the square root of 12.75 over the minimum for H. Okay, so not that one, minimum for H there. Okay, so 9.2935, and for the minimum, okay, we want the minimum value on the top and the maximum value on the bottom. So the minimum for G, which is that. Okay, so the square root of 12.65 over the maximum for H, which is 9.2945. A mistake, by the way, students make is they put these values into this as they are, and then they do the upper and lower bounds for it. Okay, so don't do that. So let's go ahead and calculate the values now. That gives 0.3842. Write out all your digits as well, as much as you can, 63033, because you're going to be considering bounds. And for the second one, okay, so that's 0.3826654431. Hopefully I've done no calculation errors, guys. So if I have done anything that you see is obvious error, do let me know and just write it in the comments. All right, so look, it says by considering bounds. So if you have a look at both numbers, can you see there's a pattern here? Look, if up to this point both numbers are the same. All right, but we're going to try to go to a suitable degree of accuracy, as accurate as we can make it. So look, if you look at the number after that, I mean, yeah, they're different numbers here, right? This one will make this go into a 3 anyway, so it doesn't match this one, which will stay as it is because it's got 2 there. So I think we can go and say to 2 decimal place, this is the answer, 0.38. So both round to 2 decimal place as 0.38. So that's why we will say this is our answer, and this is the reason that we've gone for our answer, because both of the values that we found, the maximum and the minimum, both round to 0.38 when rounded to 2 decimal places. All right, last question, quadratic simultaneous equation. Right, so with these, if we label it number 1, number 2, so look, the aim is to make on the linear one something the subject and then plug it into the quadratic. So see here, I mean, we can make x the subject by dividing the other side by 3, but it might get a bit messy when we put that x in here and we have to square that. It might be easier to make y the subject. So to make y the subject, there's minus y here. I want to move it there to give a positive y, and then minus this 3x, I'm going to move it to that side. All right, so it's going to look like this. Y is equal to 2 minus 3x. Okay, but you can make x the subject if you want. Now this, I'm going to substitute that into number 1, equation number 1. All right, so here we go. Wherever I see a y, which is here, I will put this in there and square this, by the way. So that's x squared plus bracket 2 minus 3x squared is equal to 20. So you can see here, I've plugged my y right there. I'm going to expand this out. So x squared, and I've got 2 of these brackets. So 2 minus 3x, 2 minus 3x equals 20. So x squared. Now I'm going to expand that bracket out. So 2 times 2, so I'm doing this. Okay, so 2 times 2 is 4. And then 2 times minus 3x is minus 6x, and then that's the same again, so minus 6x, and then plus 9x squared equals 20. All right, so let's collect all the like terms. So 9x squared and the x squared, that gives us 10x squared. Minus 6 is minus 12x, and then I've got this 4, and I've also got this 20, but I'm going to move the 20 over to this side, so I'm going to do 4 minus 20. And 4 minus 20 is minus 16 equals 0. That's my quadratic. Now I can divide everything by 2. So I'm going to divide throughout by 2. That gives me 5x squared minus 6x minus 8 equals 0. Again, try and factorize this. You know, if you want to, let's try it actually this time because we haven't done one of these. So 5x, we've done quadratic formula earlier. So 8 multiplied to give 8. We can use the AC method, but you know, whatever you need. All right, so what is it, 8 and 1 or 2 and 4, but we want to make the 6. I think I'm going to go with 8 and 1. Let me try 8 and 1. Nah, that won't give me the 6. How about 2 and 4? Okay, so that will give me a 10. Yep, that would work, and then I can take that 4x away. So minus and plus. Yeah, minus and a plus. So I have x is equal to minus 4 over 5 and x is equal to 2, and they are my solutions for x, but I do need to find y. So to find y, I'm going to plug it into this version. Okay, so to find y, I'm going to take this and do y is equal to, what is it, 2 minus 3x. So 2 minus 3 bracket there, and then on this one it's going to be 2 minus 3 bracket 2. Remember, you got a calculator, so you can put these into your calculator. You don't have to worry about making stuff the same and whatnot. Okay, so that's 4 over 5. I'm just putting it into my calculator, and I've got 22 over 5 for that one. So therefore that's minus 4, 5, and 22 over 5 for the x and y. And this one is, what is that, 2 minus 6. So 2 minus 6 is minus 4. That's 2 minus 4, and there you go. They are your results. All right, so that's it, guys. I mean, these are the topics that I'm predicting to come up on paper 3. Hopefully they help you. Remember, some methods more so that you need to focus on. Keep practicing these topics, and if you like this video, please do give it a thumbs up and make sure you're subscribed to the channel, and please share this with other people who are struggling with support. Maybe they don't have a tutor, or you know, they don't have links to someone who they can ask. Okay, so all the best for your exams, and see you in the next video.